So now let's derive an equation for finding the area inside a polar region. So as you can see here, I graphed this function r equals some function of theta, so r equals f of theta, and it's just, some random curve, and we're trying to find the area inside of it. So to do that, let's first look at the area of a tiny little sector. So if I kind of drew in a tiny little sector, let's find the area of that. And to do that, I'm going to graph it right here. So this is kind of a zoomed in picture of this sector. So if we take a small enough sector, this change in theta, the theta is going to just be d theta. It's going to be a tiny difference in theta between here and there. It's going to be really small. And what we're going to get is, since this is really small right here, this difference in theta, this is going to turn out to be just the sector of a circle. And we know how to find the area of a sector of a circle, and that's simply going to be our angle, which is d theta, over 2 pi, which is the total amount of degrees in a circle, times the area of our circle, which is pi r squared. Pi's cancel out, and we get 1/2 r squared d theta. But that's just the area of this tiny little sector. To get the full area of this polar, we're going to have to sum all these areas, and we know how to do that. We take an integral. So the area is going to be the integral from our initial theta. In this case, this would be our initial theta, up until some final theta, which would be right there. So from theta 1 to theta 2, of, well, just the area of those tiny little sectors, just summing those up. So that's the equation of the area inside a polar. So you guys are definitely going to want to memorize that. And now let's use this to kind of solve a trivial question, which is the area of a circle. And let's just do it with a radius of 2. So we can just use our equation. Well, our initial theta is going to be 0, and we're going to go all the way around, so we're going to go all the way back to 2 pi. And we have 1/2 r squared. R is equal to 2. 2 squared is equal to 4. I'll just write 2 squared. D theta equals the integral from 0 to 2 pi of 4 over 2, which is 2 d theta. That's equal to 2 theta, evaluated from 0 to 2 pi, which is equal to 4 pi. And the equation that we used to use to find the area in a circle was pi r squared. And if we plug in 2 here, we get 4 pi. So that works. This we can use that equation to find the area of a circle in a different way. And in the next video, we'll go over a bit of a trickier problem. But basically, the challenge in these problems usually comes with figuring out what our angles are going to be. And you're going to see that in the next video.